So this is special case products, and for special case products we've got three different formulas. One is for the difference of squares, which is if we have one binomial, which is a plus b, times another a minus b. If the terms a and b are the same in each, so that the only difference is that in one we're adding and one we're subtracting, then what we get is the difference of squares, a squared minus b squared. The other two formulas are the perfect square trinomial formulas. So if we have a binomial a plus b that's being squared, if it's addition, then we get a squared plus 2 times a times b plus b squared. And if it's subtraction, so a minus b squared, then we get a squared minus 2ab plus b squared. So notice that the only difference is that if we're adding, then the first operation is addition, and if we're subtracting, then that first operation becomes subtraction. It's the only difference between the two formulas. So, in my first example, I've got 6c minus 7d, and then 6c plus 7d. So the terms are the same. The main difference is that in one I'm subtracting and one I'm adding. So this is a difference of squares. And we know that a difference of squares comes out to be a squared minus b squared. So it's the first term squared minus the second term squared. Well, our first term is our a term, our second term is our b term. So we want the first term squared minus the second term squared. That's going to be 6c squared minus 7d squared. We also need to remember to apply the power to both factors inside the parentheses. So 6 squared is 36, c squared is c squared, minus 7 squared is 49, and d squared is just d squared. And that's our final answer. In example 2, we've got 5x minus 2 squared. So we've got a binomial, and it's being raised to the power of 2. That is a perfect square trinomial, so we know that it's subtraction, so it's going to be a squared minus 2 times a times b plus b squared. Now, if I replace each letter with a set of empty parentheses, and I come over to my problem, my first term is my a, my second term is my b. So I've got a squared, so that's 5x squared, and then I've got 2ab, so that a is a 5x, and then the b is 2, and then b squared, so that'd be 2 squared. Once again, I have to apply the exponent to both factors, so 5 squared is 25, x squared is x squared, minus, now I've got 2 times 5 times 2. 2 times 5 is 10, 10 times 2 is 20. And then I've got my x, so that's 20x, plus 2 squared is 2 times 2, which is 4. And we're done. And then finally in example 3, we've got 4x cubed plus 3y squared being raised to the power of 2. So we've got a binomial and it's being squared, and that's a perfect square trinomial. Since this one is addition, our formula is a squared plus 2 times a times b plus b squared, where 4x cubed is our a and 3y squared is our b. So we go through and we replace each letter with a set of empty parentheses. Now everywhere I see an a, I'm going to write 4x cubed. So a squared is 4x cubed squared. 2a, that's 2 and then 4x cubed. My b gets replaced with 3y squared, and my b squared becomes 3y squared to the power of 2. Now I apply my power to both factors inside the parentheses. So 4 squared is 4 times 4, which is 16. X to the power of 3 to the power of 2. When I'm raising a power to a power, I multiply. So 3 times 2 is 6. So that's x to the 6th plus 2 times 4 is 8, and 8 times 3 is 24. And then I've got x cubed y squared. So I just write x cubed y squared. Can't combine those. Plus, now I apply the last power to both factors inside the parentheses. 3 to the power of 2 is 3 times 3, which is 9. Y to the power of 2 to the power of 2. I'm raising a power to a power, so I multiply. So that's 2 times 2, which is 4. So that's y to the 4th. And we're done.